So this is the last one we looked at yesterday. You remember working on this one? And so we have one situation worked out for the monthly, and for monthly we use 12 in our formula, and continuous, this is what we have. So basically continuous makes rolling an extra 10 cents over the time. That's better. And with computers now, it's easy to keep track of. So I want you to go do number 3. And I want you to use the PERT formula as well. And I'll call on somebody to help me out up here too. And I want to give Robert some credit on this for catching on to see on the video. That was really awesome work. You caught it, and so did Emma in 6th period.
Did we finish number 2?
Did we?
Yeah, we did.
You want to see him again?
Yeah.
Yeah, we'll go back. I'll go back. So basically, if you work out the monthly formula here, monthly compounding, this is what that looks like. And then you punch that in. This is what you get as your answer. For continuous, this is what you get. And so really that's it. Do you know how to put this in the calculator? The E thing?
Uh-huh.
Everybody knows where E is? Does anybody remember what E stands for?
ETH something.
No.
E equals P. Oh.
EU.
Euler's number. I hear somebody trying to break a calculator over there on the side. Or something. All right. Okay. Euler's number. And Leonhard Euler was a Swiss mathematician. And basically this number was named in his honor. Okay, so now you're doing number 3. I'll choose somebody in another minute to help out with that.
Can I get that picture?
Pardon me?
Can I get that picture?
Oh, you need a paper? You weren't here yesterday? You were here yesterday, weren't you?
Yeah.
Okay, I'll see if I can find you one. Here it is. I found you one. All right. Let's choose somebody for this. Okay, here we go. Recruit another helper for this. It's going to be Robert O'Reilly, Robert O'Reilly, Robert O'Reilly. It's going to be Riley. That was really hard. Okay, Riley, you did this one, right?
Yes.
Okay, Riley.
Okay, so I start out with the formula, the compound interest thing,
Good.
A equals P times 1 plus R over N power up N times
Okay, like this? Okay.
T. Yeah, so then the P was 2,500 times 1 plus the rate, which was 0.05, over 4 because it was compounded quarterly.
Okay,
And then times or to the power of n, which was the 4, times 10.
so like that?
Yes, and I got 4,109.05.
4,109.05.
Yes.
So that's gonna be like $4,100, okay, $4,100. So that's gonna be quarterly compounding, right? All right. What else?
And then I used the continued one, which is A equals PE to the power of RT.
Okay,
And then the P was 2,500, and then E to the power of 0.05 times 10.
okay.
And I got 4,121.8.
21.8, 180. Okay. So this is continuous. Continuous, yeah, that's spelled right. Okay, so that's what we have. And then, of course, dollars, right? All right, questions on that? Thank you. It's good work. Right there. All right. Ready to look at number 4? Okay, number 4. For number 4, on 4A, what is N going to be? Yearly is what? N equals 1. For daily, N is equal to 365. Okay, and I want you also to do, I'll say part D, if you want to call that that. Also do this continuous too. Continuous compounding, so you'll be able also to see yearly, daily, and continuous. And see. I think it's going to be, I think the results are going to be a little bit surprising, as I recall. Yeah, that's good. Yeah, stopping at 5 would be good.
365 times 365 on the average state.
No. Because it's gonna be 365 times 1, right? Because you're talking about 1 year. And A is gonna be, it's just gonna be 7,500 times 1.06. That's gonna be part A. So you figured everything out here. You're working on it now. Okay, good work. Okay, I will choose somebody now. Who's gonna help us out with this? It's gonna be Elizabeth. All right, Elizabeth, what do you have on this one?
Well, the answer is 7950.
7950.
Yes, and then daily is 7963.73.
7963.73. Okay, and then did you do the continuous too? Yeah, just do the continue. I'll do it. That's fine. You did a good job. So what you have is your calculator. So you have 7,500 times E and we're in trouble seeing where E. There's E to the power of 0.06. Is that right? That's going to be it, isn't it? 1 year. So there it is, 7963.77. 7963.77. So you see the difference here? The difference between daily and yearly is like, what is that, $13.73? What's the difference between daily and continuous? 4 cents. 4 cents. So you can see that so basically A and B are different because different compounding periods. Does anybody need to dig into the formulas more than that? You do? Okay, for A, what you have, and Elizabeth, you can correct me if I'm wrong, you have A is going to be equal to 7,500 times 1 plus R, and R is 0.06, and it's going to be, since compounding is 1, we're just going to have to the power of 1. So it's going to be 7,500 times 1.06. For B, you're going to have A is equal to 7,500. Then you have 1 plus 0.06 divided by 365 to the power of 365. And then over here, D, continuous, you have 7,500 e to the 0.06. So I'll say I call it part D, okay?
What's the answer to C?
Why are they different? They're because of different compounding periods.
Yeah, one's daily and one's yearly.
One's daily and one's yearly, yeah. Okay? Now, what I want you to do is go ahead and work on number 5. And I'm going to show you the equation for it first. This is one that's different than the others, really. And so basically, what you have, Carmen is saving for a new car that costs $1,500 or $15,000. So that's going to be our final amount, and the initial amount that she has is $5,000, and she's going to compound monthly, so it's going to be 1 plus 0.06
Over 12.
over 12 times 12 times the amount of time. And so what you're doing is you're solving for this thing right here, this t right here. Becky, have you finished it?
Yeah, they're kind of confused with that one, that one turn into the one.
How do you do the square root where you can put whatever number you want in there?
You mean the log? You mean the logarithm? Or the square root? Or you want to do the square root?
Yep.
Okay, it's math 5.
Okay.
You want to do the 5th root or whatever root that you want looking for.
I don't know what I'm doing.
One thing you can do on a problem like this is you can solve by graphing. If you don't solve by graphing, you probably have to do an equation. I would solve it with a logarithmic equation. Anybody do a logarithm equation on this? Or did you do it by graphing?
I don't know how to do it. I just put it here.
See, there we are. I did 19 for this, and I did 19.
Okay, so a few of you got, are close to, I think, what is the correct answer. So I'll just shoot somebody for this. Because I think people are in a condition to help me now.
I guess my weight's a 19 too.
Was it trial and error? Did you trial and error it? Is that how you did it?
Yeah,
Oh,
you know where it says T on here?
Yeah.
I put 10, and then it said 19,000, so, I mean, it said 9,000.
Oh, okay.
So I put it to 20.
Yeah,
and then
okay.
it said
You were closer.
16,000, so I went down to
Yeah.
18 and said 14,000. Yeah, it has
So
to
what,
be
so what you're telling me is you did a trial and error method, kind of.
Yeah.
That's a way to do it. So it's gonna be Justin or Nicole, Justin or Nicole, Justin or Nicole. Justin,
That was right on their line.
yeah. Okay, Justin. Oh, you didn't get any farther than this?
I was putting it in the calculator.
Okay. You who solved it, how did you solve it here? You told me how you did it.
Yeah.
What about you, Becky? How did you do?
Calculator.
And then,
Well, I mean, calculator or what? What did you put in the
I
calculator?
put
How-
in the graph.
So you graphed it and worked from there, okay.
that was enough.
If I'm solving this one and I want to solve it quickly, that's probably the way I would do it. How did you solve it? You're still working on it? What about you, Elizabeth? How did you solve it?
I solved it on paper at first, but then I realized I was using the wrong formula, and I still got the right answer, so.
Yeah, I was just looking at it. Actually, I found 18.3.
Yeah, 18.3 is about right.
Yeah.
So really, a couple different ways of doing it. One is take this here. So if you take 5,000, that's where it is, right? Times 1 plus, it was it compounded monthly?
Yep,
And was the rate 6%?
yep.
0.06, 12, yeah, 12, that's right. Okay, to the power of 12x.
Yep.
We'll try to find x. And if we subtract out 15,000,
Okay, I did that.
so we have that. Now, the key thing is, you're gonna have to have a window that's gonna be, because if you just press graph, you're not gonna see anything. For one thing, you know that the starting value is gonna be a lot higher, so you can adjust, play with your window and get this up here, your Y max to, I don't know, 10,000 or something like that. And then, let me get this Y scale down to 1. So you can kind of just play with the graph.
One's on a 10,000 and one's on a 1,000 scale.
Yeah. Still don't see it.
You put one on a 10,000 and one on a 1,000.
That's what I wanted to do.
Oh,
That was what I wanted to do. Let's go take the, let me see what the table view is. Oh, it's going from negative. So that explains something here. So let's do that. And go to, because then we'll see it. So we go to negative 10,000. 2010, yeah. So now we see it over here, right? So all we need to do really is get the window bigger, and get the window bigger. I'm going to go to 25. And so now we can see where our x-intercept is, second trace, 0. And it says left bound, press enter. And then we go to the right. Press enter twice. 18.35, so that many years. Is that a good strategy for Carmen to save for a car?
no.
She's saving for a car right now, but what she's going to need then, she's going to need a minivan for the kids she's going to have between now and then, right? It's going to be a whole change. Another thing is that car she wants to buy today for $15,000, what's it going to be worth 18 years from now? $500. So she's going to have to make other arrangements to, yeah. And then logarithmically, there's a good way to solve it too, but we'll just kind of leave it there with that one. I want to get, there's another exercise sheet that has this type of problems, but I think we're going to be okay on that. What I want to do